For this question, there will be multiple versions that you should look at, and they will come up different scenarios, and you will try to determine if it is a binomial distribution or not. So there's an attachment here. Let's take a look. This is how we know if we have a binomial distribution or not. There are three characteristics of a binomial experiment. One is that there are a fixed number of trials, n. There are only two possible outcomes, which can be thought of as success and failure, or possibly viewed as favorable and unfavorable. The third requirement is that the n trials are independent, and also that each trial has the same probability of success. So we summarize this by saying constant probability from trial to trial, the same probability of success every time. All right, so this example, I don't think this is the right one. I lost my question. Maybe I have to, oh, there she is. Okay, we found her. Okay, so let's look at some different possibilities here. The first one is determine whether the given procedure results in a binomial distribution. If not, give the reason why. Okay, first of all, rolling a single die 34 times and keeping track of the numbers that are rolled. All right, so we want to check the three requirements. Remember, we want to know if there's a fixed number of trials, rolling a single die 34 times, and keeping track of the numbers that are rolled. Okay, well, we are rolling a single die 34 times. So we have the fixed n, which is 34 in this case, because that's the number of times we're going to repeat the procedure. Also, we have that there are only two possible outcomes per trial on each trial, and the trials are the roll of the die. So what are the possible outcomes? Are there only two? That's what we're looking to see. Well, when I roll a die, what are the things that could come up? I could get one dot on top, 2, 3, 4, 5, 6, right? So that would mean the answer to this requirement is no. There are 6 possible outcomes. So that means this is not a binomial distribution. Or you could say not a binomial random variable, because the random variable x is the number of dots on the top facing side after it's rolled. So that's the reason we say no to this one. So not binomial, there's not a, no, it's not that one. There are more than 2 outcomes per trial. There we go. Okay, so that's how we answer that one. Now let's look at a similar question. Choosing 5 marbles from a box of 40 marbles, 20 purple, 12 red, and 8 green, one at a time, without replacement. Okay, so before I even go any further, right when I read without replacement, I know this is not binomial, because if it's without replacement, then your probability of success is going to be changing from trial to trial, because every time you take a marble out, it changes the ratios and therefore changes the probabilities for the trials that would come successively. So I already know the answer is that it is not binomial, because already we don't have constant probability. So that's one reason. Not binomial, the trials are not independent. All right, so to see how this would play out, let's look at it in a, let's get the spreadsheet here. Okay, so choosing 5 red marbles from a box of 40 marbles, where we have 20 that are purple, we have 12 that are red, and 8 that are green, and our total that is 40. One at a time without replacement and keeping track of the number of red marbles that are selected. So if X is our random variable, it would be defined as the number of red marbles that are selected when we select however many marbles. Okay. Now, the other reason that this might not be considered or is not considered a binomial distribution is I don't think they've specified how many times we're going to choose a marble. Oh wait, no, it's right there at the beginning, choosing 5 marbles. Okay, so then the n is 5. We do have a fixed n. Okay, so that is satisfied, 5 marbles. Okay, so how many of the 5? So to see why the constant probability is a problem is because on the first selection, to get a red marble, we have 12 out of 40, right? And then on the second time we pick a marble, we would only have, assuming that we've already taken out a red and not put it back, we have 11 out of 39. So right away we see on the second trial a different probability of success than we had on the first trial. And this will continue through all the trials. Just adjusting the probability to reflect the fact that we've taken out a red marble and not put it back. Sorry, my numbers are all messed up here. Okay, so now we get the idea of that, right? Well, what are the other requirements? One, we have a fixed n, which is 5 here, so that was satisfied. 2, that there are only 2 outcomes per trial. Now that is true because what we've boiled it down here is either red or not red. So if we're only looking at the marble to see if it's red, then we only have 2 possible outcomes, yes or no. So that one is satisfied as well. So the one that is not satisfied is the constant probability of success. So that's not satisfied. The other 2 were fine. So our best answer is the one we've already selected, that it's not binomial because the trials are not independent. Or in other words, the probabilities are going to be affected as you go along. Okay, let's try another one. 5 teachers at Springfield Elementary School are randomly selected without replacement, and the number of years they taught at the school is recorded. All right, so as I'm getting this set up, can you identify a fixed n? Are there only 2 possible outcomes per trial? And do we have constant probability of success, or do the probabilities change as you go along? So first of all, fixed n, yes, n is 5 because we're selecting 5 teachers. 2 outcomes per trial, only 2 outcomes per trial. And that would be no here. Why is that? How do I know that the answer is no? Because the random variable x equals the number of years they taught at the school. So let's just do a quick example to understand what we're doing here. Teacher 1, the first teacher that's selected, maybe that person has taught 3 years at that school. And then maybe teacher 2 has taught 5 years at that school. And teacher 3, maybe only 1 year. Then maybe another couple of teachers had been there a long time. And so we had one like 15 years and maybe 18 years. So as you can see already, I have come up with 5 different possible answers that these teachers could give. So it's definitely not binomial because there are more than 2 outcomes per trial. And thirdly, does the probability of success remains the same from trial to trial? Well, that is kind of a pointless question, or a question that's unanswerable, because there are not, uh, because the random variable values can't be boiled down to success or failure. Can't be summarized as success, failure. Okay, so let's see what our answer options are here. Okay, so there were a fixed number of trials, so we can ignore the first option. There are more than 2 outcomes per trial. That's true. The trials are not independent. Well, that's not really true. But the binomial for more than one of the reasons the procedure results. I believe that this is the best answer here, but technically you could say that also we don't have constant probability of success. But I still feel like the best answer is the first one, so I'm going to go with that. Okay, so notice that really we probably should have chosen that there is more than one reason, since we also can't say that there's a probability of success from trial to trial. Okay, so should we do another one? Maybe one more? Rolling, oh, okay, so that's the same. Oh, no, this is a different one. So this is rolling a die again, but it's worded differently. It's a different scenario. When we looked at the one before, it said we were keeping track of the numbers that are rolled. So there was a possibility of 6 answers each time you roll. Here, when we roll the die, it says we are going to be keeping track of the number of 3s that are rolled. So 1, n is 34, so that's satisfied. 2, there are only 2 possible outcomes, because the 2 possible answers or if you think about what the question is, so the random variable x is number of 3s rolled. So every time you roll a die, the question is, did it land on the number 3? So you will either answer yes or no, right? So that is the reason that there are only 2 possible outcomes in this scenario. The third is that the probability of success, and what would be a success here, is rolling a 3, is 1 out of 6 every time the die is rolled. So therefore we do also have the independent trials with a constant probability of success. So this is a binomial distribution. Okay, so I think that's pretty good, and we'll stop there.